Hello all, welcome to a new video on logic design. In this video, I have explained the minimization of SOP expression using a two-variable K-map. I have created a separate playlist in my channel for the simplification of K-map where I'll be explaining about the 3-variable, 4-variable and 5-variable K-map in my subsequent lectures. So this video is the continuation of my previous video on the mapping of SOP expression using a two-variable K-map. If you are new to my channel, check out my videos on the selected topics from the course of logic design and also a few videos on the solutions of the previous year question papers of logic design. The links of all those videos have been given in the description box. So without further delay, let's get started. Minimization of SOP expressions. To minimize the Boolean expression given in SOP, we have to look for adjacent squares having ones in the K-map. To minimize the Boolean expression given in SOP form, that is sum of the product form. The Boolean expression can be in SOP form or POS form, that is product of sum form. So to minimize the Boolean expression given in SOP form, we have to look for adjacent squares having ones in the K-map. And we have to combine them to form larger squares to eliminate some variables. That is, we have to reduce the Boolean expression. So in order to reduce the Boolean expressions, we have to eliminate some variables by combining these squares or cells. Two squares are said to be adjacent to each other if their minterms differ in only one variable. Let us consider an example here for a two-variable K-map. The two-variable K-map consists of 4 cells or 4 squares. 1, 2, 3, 4. These are the 4 cells or 4 squares. The variables are A and B. These are the variables. There are 2 columns, that is 0 and 1, 0 or B bar, 1 or B, and 2 rows in this K-map, 0 or A bar, 1 or A. 2 columns and 2 rows. And each cell is represented by its minterm, that is minterm M0. This cell represents the minterm M0, this cell represents the minterm M1, this cell represents the minterm M2 and this cell represents the minterm M3. Now we are going to place ones in these two cells, that is M0 and M1. These two cells are adjacent to each other and it contains ones in these cells. Therefore, we can group these cells. There is another criteria for grouping, that is, first you have to read the cell name. So what is the name of this cell? This cell belongs to first row, first column. That is, first row is 0 or A bar and first column is B, 0 or B bar. Therefore, the name of this cell is A bar, B bar or M0. M0 is the minterm. Similarly, we can read this, the name of this cell, it is A bar B. This is first row, second column. First row is represented with the literal A bar, 0 or A bar, and the second column is represented with the literal 1 or B, with the literal B. Therefore, the name of the cell is A bar B or the minterm M1. Now, in order to group these cells, here one variable should differ in these two terms, A bar, B bar and A bar B. One variable should be different and the and one of these variables should be constant. So in this particular case, first variable is constant. It is a bar. First variable is a bar in both these terms, and the second variable changes. The second variable is b bar in this case, in this term, and here it is b. In this term, the second variable is b. Therefore, b bar changes to b. So whichever variable is changing, that variable should be eliminated when we reduce the SOP expression. So first of all, let us group this once since it satisfies the condition. That is, one variable should differ. So this is the variable, second variable differs, and the first variable is constant. Now we are going to reduce this SOP expression by eliminating the variable, the second variable b, that is b bar changes to b, you have to eliminate that, and the first variable a bar is constant, we have to retain it. Therefore, by combining these two cells, we are forming a big cell. Thereby we are eliminating one variable here. Therefore, F1 is equal to a bar. A bar is the term that we are going to retain here. A bar is the variable that we are going to retain here because it is constant, and the second variable, since it is changing, we have eliminated that. Therefore, the reduced SOP expression is F1 is equal to a bar. Now let us consider another example of a two variable K-map. Here we are going to place the ones in the cell numbers 0 and 2. That is, the min term 0 and 2. Since these cells are adjacent to each other and it contains ones, we can group this ones because it satisfies the condition to group this ones. This cell is called as a bar b bar, that is, or m0, and this cell is a bar a b bar or m2. Here you can notice that the first variable differs. Here it is a bar, here it is a. So the first variable differs or changes from a bar to a, and the second variable is constant. Here the second variable is b bar, here also the second variable is b bar. So the second variable is constant and the first variable is it differs. Therefore, we can eliminate the first variable and retain the second variable. Therefore, the reduced expression is F2 is equal to b bar. Now let us consider another example. Here we are going to place the ones in the cells M1 and M3. Since these cells are adjacent to each other and it contains ones, we can group these cells. This cell is called as the min term M1 or a bar b, and the second cell is called as M3 or AB. Here the first literal is changing, the first variable is changing from a bar to a, and the second variable b is constant. That is, the second variable is constant and the first variable is changing. So we can eliminate the first variable and we can retain the second variable. Therefore, F3 is equal to b. Now in this case, we are going to place ones in M2 and M3. Since these cells are adjacent to each other and it contains 1, we can group these cells. This cell is called as AB bar or M2, and this cell is called as AB or M3. Here you can see in these two terms, the first variable is constant. Here it is A, here also it is A, and the second variable changes from b bar to b. Therefore, the second variable is eliminated here and the first variable is retained. Therefore, F4 is equal to A. This is the reduced SOP expression. Let us consider one more case here. Here we are going to place ones in all the cells. That is all the 4 cells M0, M1, M2 and M3. So you can see here this M0 is adjacent to M1 and M2. M1 is adjacent to M3 and M0 and this M3 is adjacent to M2 and M1. So we can see all these ones are adjacent to each other. Therefore we can group all these ones together. Here this first cell is called as A bar B bar or M0. Second cell is called as A bar B or M1. Third cell is called as A B bar or M2. And the fourth cell is called as AB or M3. So here you can notice when you see the variables here, it differs. The first variable is constant here, A bar is constant, B bar changes to B. Therefore, when we see these two ones, we can eliminate one variable here and retain A bar. And in this case we can retain B when you compare this. So in each case when you compare with the adjacent cells, the variable is differing. One variable is differing and the other variable is constant. Therefore this Fi is equal to 1. That is, all these terms will get reduced to 1.